So good afternoon all. I am Vella, technical engineer from SuperMap International. Today it is such a great honor for me to be here to be able to present the topic in SuperMap webinar Mongolian. Thank you for the chance, and as said earlier by the host, I will present a topic of SuperMap solution for mobile surveying and 3D Cadastre. Please enjoy the presentation. So I divide this presentation into two main topics. As the first topic is mobile surveying. I believe that some of you may be familiar with this topic. Therefore, in these sections, particularly, I'm going to show you one of mobile surveying method using GIS mobile applications. So let's begin the presentations. So we begin with the questions, why mobile surveying is needed now and what makes this important, which will be elaborated on the background. So the first reason, we all know that some organizations or institutions needs to configure a workflow to maintain their data. And their data probably probably have their own existing data, but sometimes some data needs to be collected from scratch in the field. Even if they have their own existing data, they still need to validate the data, whether the data is correct or not. And also there needs the data to be assessed and updated with the current conditions in the field. Therefore, they need ground truthing. And the second main reason, while we collect the data in the field, sometimes we also want to collect any information available in the field, such as we want to collect data by capturing the assets or by taking an image, or we want to track the locations of the assets or even just to navigate. And this point are the main reason why we need mobile surveying to make those works effective. So now what do we need? Actually, to make the things work, we need some of these capabilities to be available on our mobile surveying applications. The first one, we need a data collection app. We need the application which can work offline because sometimes in the field there are no good internet connections. And also we need the application to be able to capture assets and inventories, observation location tracking, perform inspections, editing and analyzing capabilities functionality. And last but not least, we also need the applications to be able to import, store spatial data, and also do some measurement or computational method works. So how to use it? So this slide is going to show you the example on how we usually use the application for those capabilities mentioned before. And the first pictures explain on how we collect assets and data. We could input the data, we could input some text, information, or attributes data following the assets. And the second pictures explain on how we capture observation data by taking pictures and store it in our database. And the last example, pictures explain on how we do on how we perform the data editing. And we could edit the existing data, overlay with other data available on the applications, or show the base map to make us know some idea about the location of the data in the real situations. So here, I will show you a simple workflow to make you easily understand on how these applications in an operational case works. So as you can see, the field workers using the mobile applications to collect the data. In the applications, it includes the data layers, web maps, photo, or even maps template. And the field worker can use the application offline and online. If they use it as offline, later if they have the connections, they can synchronize the data and send it to the back office. So what does the back office do in this case? The back office can manage the maps template for the field workers so that the field workers have already known which data needs to be collected or updated and which information needs to be inputted. And this template can be as preliminary planning, And besides, after the data collected and updated, back office also can manage the data in the desktop applications, or if they want to publish the data, they can publish it in the web application, so it can be accessed online by public. And you need also you need to notice that the synchronizations doesn't only mean they only can sync the data using connections, but there are also some other ways out, such as send the worst data to others and copy the data which is stored on the local devices to other devices. So SuperMap has the solutions for these issues. We have launched a SuperMap iTablet, which is a universal mobile desktop applications to get rid of the limitations of time and also space brought by manipulating geographic data on PC, while GIS users can process the data anywhere and anytime. It doesn't require any development and can be used in the industry-wide surveying and mapping. It can run on iOS and also on Android operating system, and it includes abundant functionalities used in various industries. iTablet also allows you to operate your data through your finger movements. So here, SuperMap iTablet has 8 function main modules. Those are collections, mapping, scenes, video mapping, navigations, thematic map, plotting, and data analysis. If SuperMap iTablet has the connections or working in online environment, iTablet can perform the data sharing, which sync from iTablet to iDesktop, which is our desktop application. So we will get through each main modules, which will be started from the data collections. So let's take a look at the first main modules, data collections, and we will elaborate which functions available on these modules. So as you can see on this image, inside this module, we do have many data collections tools to collect our data in the field. There are many methods on how we collect the data. We can collect the data by draw manually a point, polygons, and also line, or we can connect our mobile GPS, our mobile applications into GPS so that we can collect the data based on our GPS locations. And this also can be applied for the data tracking. We can set the intervals on how long we want to collect the data for each tracking data. And we also can collect the photo as marker and store it in our database. And not limited to those mentioned above. It's in this module, we are also having topology captures and topology editor to check our data. And besides, do not forget that we also can store the information inside of the objects by inputting the attributes. So here is the workflow for data productions. First stage, we should collect the data in mobile. And we store the spatial information and also attribute information of each object. After we collect the data, obviously that we need to process the data, such as editing, set the layer style, creating map, or else. And we can do it in our PC or even in this mobile app. And the last steps, we are going to analyze and make the applications of the data we're collected in PC or mobile. So now we're moving to another modules, which is the mapping. Actually, for mapping, we have the functionality in 3 main modules, which are mapping itself, thematic map, and also the plotting. So let's take a closer look on how this modules works. But before going further on the mapping modules, I will share to you the mapping operations tabs on this iTablet. If we want to do mapping, the first steps we need to do is import or open the data which is stored in our local mobile storage or online, or we access it online. After that, we can make a thematic maps based on this data. There are many types of thematic maps which can be created in these applications. Those are single value style map, range style map, and unified label maps. And the result will be like this. And not only like this, I also want to share you the another results of this mapping functionality. This is the another mobile mapping result. So it proves that we are not only can use PC or desktop applications to create a beautiful and meaningful maps, but we also can create this kind of maps using the mobile applications. We can create land use maps, political maps, precipitation map, science and education map, and agriculture's map. And the next one, we have the data analysis modules. So we all know that in GIS, we commonly use the spatial analysis. But what is the spatial analysis? So spatial analysis is an analysis technique based on the locations and the shapes of geographical objects. And this picture shows the example on the applicative of spatial analysis after being used. Suggest we use the flood analysis here to show the affected area based on the DM data or the elevations data. And we have the road buffer analysis and also site selection analysis. The site selection analysis basically commonly used by the retail industry. Next, we have a navigation main modules. So in this module, we have an indoor and also an outdoor integrated navigation as displayed in the following pictures and videos. And we can pick a start point and also end point. And these modules will show the route or navigations to reach the end point. And there will be some animations to like display in the video. And the last main module which will be explained on this presentation is the video maps. So SuperMap iTablet can display an AR video map, show real integration of 2D and 3D, and it can show data for indoor, BIM, and also can achieve the AR plus GIS. This is the first video. I have another video, but I believe that you already seen this video in Jason's PPT, so I will skip this one. And this one shows that SuperMap iTablet also has high performance maps operations. With the large image map, it has fast rendering and also can store many kind of maps like a vector format, grid format, vector tiles, and others. And this is the most exciting part of SuperMap iTablet. So we can achieve the data sharing in multi-terminal interactions. So if one device can send the data, while other devices will receive the data dynamically in the real-time situation. And it will increase the time efficiency. So here, before we talk about the ready-to-use application, which is the SuperMap iTablet, but SuperMap also has the development platform, which is WebGIS. This is a customization platform, and the technology speed is very fast than we think. So we should think faster how to make the work more efficient and effective in this industry. Sorry. And using the SuperMap mobile GIS, we can easily customize the mobile application based on our needs. We can show our data, analyze it, integrate it with 3D and other capabilities. Except of that, we can also make it online and also offline, such as if you need mobile surveying on the field, we can provide the offline mobile GIS and you will store your data on your mobile phone if you don't have any internet, or you can directly make it stored into your database center. If you have connected to internet, it's flexible, right? So based on the slides I explained before, I guess we all have the idea what the advantage of using the field surveying by mobile applications. If we use offline method, we can achieve the power saving and also mobile data saving. But if we use online method, we can achieve memory saving and dynamic interactions because we can sync the data every time the data updated. And we can also achieve high efficiency if we use the mobile app to the field surveying. So based on the slides I explained before, I guess we all have the idea what the advantage of field surveying using mobile applications are. So if we use the mobile offline method, we can achieve the power saving and also mobile data saving. But if we use the online method, we can achieve the memory saving and also dynamic interactions because we can sync the data every time the data updated. So we can also achieve the high efficiency if we use the mobile application to the field surveying. And as the data managed correctly, it can also be searchable by the users. Yeah, so that's all about the mobile surveying. Next part, I will show you about the cases. So these are some successful cases of mobile surveying developed by SuperMap. We have the Marine Monitoring Law Enforcement Project, National Census Project, POI survey projects, and any others projects. Here is developed by our mobile applications, not only SuperMap iTablet, but also mobile GIS development platform. So now we're moving to the second part, which is the 3D Cadastre. Actually, the first part and also the second part is not really connected with each others, but since these two are the main popular topics in this industry, so I think it will be better if I can deliver you these two kind of topics in the limited time like this. So now we are entering the second stage here, which is the 3D Cadastre. Currently, not every country has implemented this 3D Cadastre technologies with many reasons. It can be about the legal aspect or technology itself. Well, let's talk about the definition first. The definition of the 3D Cadastre. 3D Cadastre actually can be interpreted as a system of cadastral register and provides an insight on the authority of right and restrictions, not only parcels of land, but also the 3D property units. So the background why we present this topic, because we all know that as the increase of population growth while the availability of land supply remains unchanged, 3D cadastre becomes important to be implemented in this era. Intensive use of space above and also below ground surfaces are the factors which makes 3D cadastres needed. Value of properties getting higher and higher, and therefore we need a legal status on utilization of spaces. It is difficult to achieve the spatial aspect of rights for the 3D properties you need in the 2D cadastral registration system. But we all know at the same time, there are many technical improvements that can support implementations of 3D cadastre nowadays. So what does we mean by intensive use of space? We can see here on the pictures, we use the underground and also overground of space like this, like underground pipeline, tunnel, well water, apartment buildings, sewer, underground parking lots, shopping center, and many more. So we must know about the legal status of this kind of properties you need. But now in this presentation, we're not talking about the legal aspect, but we will review the technologies itself that are available in the GIS industry to help realizing 3D cadastre. For example, we will show you how to update the 2D and 3D models for buildings, how to connect the attributes with 2D and 3D data, unify the standard for cadastre data, and how to perform the legality checking for the analysis, and how we share this 3D cadastre into the public. So here's the workflow for the 3D cadastre technologies. It starts from the data management to digitizations, and then 3D modeling and also visualizations. We will talk about it in the following slides. So now the data management first. So for data management, SuperMap has SuperMap SDX Plus, which is the spatial data engine for SuperMap GIS products. It used to store access, index, and update the spatial data. And all of SuperMap products has this SuperMap SDX Plus built in them. And SuperMap SDX Plus support mainstream commercial relational database platforms, including Oracle, Oracle Spatial, SQL Server, and etc. And also we support the web engine. And for the business data, we divide into two main parts, the integrations of history data and the data updating system. The old system of integration tools for history data, which stores Cadastre history database, will be accessed as the history data by data updating system to create the updated Cadastre database on the system. And it will make sure that the database store existing history data and also daily updated data for following functionality for 3D Cadastre. And SuperMap iDesktop can handle large variety of data such as vector data, which is like shapefile, which are shapefiles, DGN, DWG, CAML, CSV, and others, and also the image format, and also the models, 3D models format. Now we also support the CTGML. Okay, the process called digitizations can help us to identify the content of attribute informations and spatial informations to easily compute in the software. For example, a scan paper shop drawing of a building or say CAD data can be converted into vector data by this process. And in the software, the digitization process has been customized so you can do it directly from the cadastral vectorization toolbar that contains all the tools you need. And this is our existing 3D cadastre cases in Turkey. And you also can take advantage in time by using the batch import options if you are work in separate data sets, and you can choose more than one file to import, so the digitization process can cover all your drawing sets at once. And this is a video showing how efficient the digitizing process in SuperMap iDesktop, because all the tools and interface are user-friendly. And here we go by the importing process of drawing data. And we can drag it into the map here. And we can do the drawing scale corrections. We'll go to it really fast. You can also do the batch clip here. And then we can also do the factorizations, batch registrations, or we call it georeferencing. We can also like digitizing rectangle of the floor plan. So here you can also see that we can also display this floor plan or the 2D factors into the 3D. So we can display the the floor for each floor, and we can display and query the attribute information on the 2D and 3D. So digitizing process are basically data conversion or factorization to help us understand the data and make it so much easier to analyze in GIS. And the workflow are as simple as before we have the vectors data from drawing that have been digitized. Then we can overlay the data with another vectors data or the base map. And we can stretch or extrude the 2D vector to 3D vector with dividing attributes that contain information about elevations or floor plan. And here I will show you that we can directly change the floor attribute value in the table and in the display. Especially the 3D display will change directly based on the attributes value that we inputted on the table cadastral filter display. And with all the tools and ability of SuperMap iDesktop, we can integrate several kinds of 3D models and still connect it to the database and attribute value by matching it with the vectors data. And here is the model, the SuperMap iDesktop 3D symbols. So we provide rich and realistic 3D symbols for many purposes, such as for city furnitures like trees, fire hydrant, valve, or cars, bus station, and also railway, and many more. We have many more 3D symbols that are available in SuperMap iDesktop. And this 3D symbols is actually can help us to create a digital twin precisely with the reality and give us a vivid image of interpretations in 3D models. And SuperMap also support the capabilities of publishing GIS services using GIS server. It can publish 2D and 3D integrations, surface, manage, and integrate these services. So we publish these services by using our server, which is SuperMap iServer here. And for 3D, we use SuperMap iClient 3D for WebGL. So this is a plugin free and cross-browser client in the structure of SuperMap iServer products. iClient 3D for WebGL is characterized of rich contents, quick response, and also smooth experience of 3D real space. So I believe this one is already explained by Jason too. So I just explained a bit about this one. So the WebGL client has flexible interactions and rich data display, and it is compatible with other frameworks. It also compatibility between devices and also browsers. And for PC device type, the compatibility browsers are Internet Explorer, Google Chrome, Mozilla, and also Safari. 3D WebGL also support multifunction of online analysis for 3D surfaces like sectioning, measurement, 3D analysis, scene configurations, visualizations, and 3D editing. And we also can display it in mobile, in multi-type mobile terminals such as the following pictures. And besides visualization, SuperMap support the information query to display the attributes information of each unit. So we can also see the legal status here on the attribute information if we have any. And the last one is the analysis. So before we talk about the data structures and also the database and also the processing visualizations, now we do now after the visualization we need an analysis. So in SuperMap we do have the analysis that is applicable for 3D Cadastre, which is the 3D legality, and SuperMap use 3D Designer to do the head control analysis. And also we have the legal distance detections here to know the maximum distance of the building from the roadside. We do also have 3D spatial analysis, which are visible analysis, skyline analysis, shadow analysis, and openness analysis. Actually, we have many more, but I cannot put it all on the presentations. Yeah, so this one is all about the 3D Cadastre. So I'm going to show you about the cases on the application of 3D Cadastre. So here, besides the Turkey's cases, we have also the 3D Cadastre in China. In this case, emphasize the rapid development of Chinese cities. We have the large populations, smart cities, and therefore, for management of real estate, we must quickly achieve information technologies by using the 3D Cadastre. And this one is also the cases in Chinese. We have this case emphasize the rapid development of Chinese cities too. We have the Smart Street Operation Center, which is in Beijing. We have the 2D and 3D integrations or visualizations, and also we have the night scene mode. We have the case management, patrol management, CCTV integrations, and early warning information. So this is the last part of my presentation. Sorry if I'm speaking too fast because we have only limited time here in the presentations. So this is the review. By applying or by implementing 3D Cadastre, I believe that we can achieve the integrated data management, efficient digitization process, effective 3D modeling, and also flexible visualizations. So yeah, that's all about the presentations. I hope that in this very limited time, we can have a better idea on how implementing the mobile surveying and also the 3D Cadastre in our countries based on our industry's needs. So thank you for your time. If you have any questions, please feel free to contact me in this email, vella@supermap.com, or you can also put the questions to other colleagues and to our website. So thank you very much for your time. Have a good day.